Hello, everyone. Good morning, good afternoon, good evening to everybody. We have been really tied up with several activities. So I hope all of you are comfortable getting into the go to link. Is everybody okay?
Yes,
So,
Dr. Purnima. I'm Satya here. Yeah, good, good. Thank you very much for all the arrangement. Yeah.
yeah, it's the team has been struggling. In fact, I've kind of been chasing them since yesterday for several things. The audience will be on a YouTube link. Only the participants or panelists are going to be on this link. So we have your presentations. You could try to share, or we could share it for you, depending on your convenience.
Yes, yes. I prefer to share myself easier.
Fine, no problem.
All right.
Sometimes it
Thank
doesn't
you.
work. Sometimes we could take over. Okay.
Sure, sure.
We are just coming out of another event. The director will join shortly.
So back-to-back events and meetings. Yeah.
Back to back. Just simply too many
Okay.
things going on at the same time.
Understand, understand. Yeah. Thank you, thank you.
I was just wondering, Dr. Panima, will the meeting be recorded?
Will the meeting be recorded?
Yes, sir. The meeting will be recorded, sir.
Lovely, thank you.
Yes, we would like to. If somebody asks for any presentation, so we'll be recording it.
Hi, Martin.
How you doing, Satya?
Yes, yes. Good. So we will wait for until 6, yeah? Right?
Yeah, start on time, I think. Yeah.
Okay.
Morning, Louis. Morning, Pat. Must be very early in the morning for both of you.
So I think we are all set to start. Thank you everybody for joining at various time zones. Dr. Vega, we are really sorry. Also, Patrick, it's really early for you. Um, Everybody else in all the time zones, morning, good afternoon, good evening. Our director is just about to join us in a minute because we are running back to back. Several events are going on today. So we'll just start shortly, maybe in just a minute or so. Please bear with us. I welcome you all formally, and this is a very different kind of a webinar we have arranged today. It's sponsored by the Ocean Energy Systems Technology Collaboration Program under the IEA. We have also brought in several people from different countries to give the talks today. So let's hope we all come out with a lot of inputs and information. So we'll just start formally in a couple of minutes. Thank you for joining. Oh my God. Okay, start.
Good afternoon. On behalf of National Institute of Ocean Technology, I welcome you all for the OES webinar on OTEC, some developments and way forward. Ocean Energy Systems, OES, is a technology collaboration program, an intergovernmental collaboration between countries founded in 2001, which operates under a framework established by the International Energy Agency in Paris. OES covers all forms of energy generation in which seawater forms the motive power through its physical and chemical properties such as waves, tidal range, tidal currents, ocean thermal energy gradients, and salinity gradients. One of the objectives of the OES is to motivate researchers around the globe to explore renewable energy resources related to sea. With that objective in mind, a webinar is arranged today on OTEC. As is the Indian tradition, I request Dr. G. A. Ramdas, Director,
This
NIOT,
conference will now be recorded.
to start the event by lighting the lamp and welcome the gathering. Thank you. I now request Dr. Yan Murk, Chair OES, to present the OES perspective on OTEC. Oh, I'm sorry. Yeah, I'm sorry. I request Dr. Ramdas to welcome the gathering.
Good afternoon. I think Mr. Meka knows that I am gasping for my breath. I came running here If you wanted to give me a break. Thank you. I'm sorry if my pronunciation is wrong, but I welcome Dr. Anne Hervé D. Roque, Dr. Anna Brito E. Mello, Dr. Patrick Grandoli, Dr. Brian John Cloet, Dr. Nadia Pebina, Dr. Purnima Jalihar, many other distinguished invitees, participants of the workshop, and Dr. Vijay Kumar from Ministry of Earth Sciences, and my colleagues from NIOT. Once again, good afternoon and welcome to this OES webinar on OTEC, some developments and way forward. We get to hear a lot about non-conventional energy resources and renewable energy resources. But many of them have some limitations. They have some spatial and temporal variations. For example, waves are actually not very packed with energy in tropical weather and areas. And even actually that sunlight is actually diurnal, and tides can be diurnal or semi-diurnal. So they all have limitations. But if you see ocean thermal energy, it is truly renewable energy available throughout the world, except maybe some polar regions, and available throughout the year without any problem. So it's actually, if judiciously and efficiently tapped, it's definitely a good source of energy. And coming to NIOT, NIOT was started in 1993. Our first project was to extract energy from the ocean waves. We demonstrated in one of the west coast of India, and after successfully demonstrating and after successfully experimenting with lots of turbines, different kinds of turbines, we moved on to OTEC. With our limited resources, with our limited experience, we ambitiously started deploying a long cold water pipe of 1 kilometer length and 1 meter, more than 1 meter diameter. We had a limited success. In fact, there were some minor mishaps. I don't know, I cannot say it is my privilege, but at least misfortune to see I was the last person to see this OTEC pipe deployed in east coast of India. After that, we could not continue that project, but we converted that into a more successful LTTD program, that is low temperature thermal desalination program. Based on the same principle, actually, we have drawn the water from the depths of the ocean, and we demonstrated this low temperature thermal desalination in some islands of west coast of India. They're called Lakshadweep Islands. At 3 places, 0.1 MLD plants were installed, and those prototype plants are still serving people after a decade. Based on this success, we were asked to install 6 more plants there. Now the process is on. The one project that is led by Dr. Purnima and being executed by her team is establishment of OTEC-based desalination plant at Kavarati Island of Lakshadweep. And I'm happy to inform you that the work is going on very well. In fact, Dr. Purnima is going to initiate the project work there another 2 days in Lakshadweep. Once it happens, I dare say that it's one of its kind in the world, and I hope it will rekindle the that interest in OTEC. And I believe that with the advent of generation of hydrogen at site in oceans and storage of hydrogen there as energy, I think OTEC will see really a good boost in coming days. So realizing this one, Government of India led by Honorable Prime Minister of India, Sri Narendra Modi, announced a deep ocean mission, a big project of around more than $500 million spanning 5 years. And it has 6 verticals, and 1 vertical is on studies on ocean thermal energy conversion. So it augurs very well for the re-advent of OTEC. And I'm sure all these issues will be deliberated and discussed in today's webinar. And I congratulate the organizers for coming out with this brief but very effective agenda. And I wish you all the best in coming few hours. Thank you.
Thank you, sir. I now request Dr. Yan Ulve, Chair OES, to present the OES perspective on OTEC.
Thank you very much. Can you hear me? Yes, I think so. Thank you very much to give me the floor after Mr. Ramadas speak. So I'm very happy to launch this this webinar on OTEC. I mean, it's a very important topic. Can you see my slide?
Yes, sir.
Yes. Okay, that's great. Okay. And so I'm actually the chairman of this technology collaboration program on ocean energy systems under the umbrella of the International Energy Agency. And by the way, I'm the French delegate in this group of experts, and I'm the executive director of an institute, which is a public-private institute devoted to offshore renewable energies in France. So the presenter from NIOT gave a short presentation of what the OES is all about, and I just want to just to recall after that yes, there are these groups of experts, 40 of them, and there's one of them which is really devoted to so ocean energy systems, which encompasses OTEC. But I would also say that we have many links or many common topics with other TCPs. For instance, with wind, because there is offshore wind and also floating offshore wind, and many of the issues that we encounter and that OTEC might encounter also with floating systems could be shared with this TCP. There's another one which is, I think, very important to talk about, which is heat pumps, because you know, there's these seawater heat pumps and also SWAC, seawater air conditioning, which has many connections, of course, with OTEC, by the fact that deep water has to be pumped to the surface, to the shore, or to the surface, and that's quite important. Then, so OES, as it's been said, is related to all these techniques, technologies that harness the energy from the physical properties of the ocean. So wave, tidal range, tidal current, ocean currents, OTEC and salinity gradient. That's been said too. But the fact that OES is a group of experts, it's important to show that we have people coming from different kind of stakeholders, which can be governmental department, industry, academics, utilities, and so forth, and that what makes all the interactions we have in OES, I think, so interesting and fruitful. By the way, we have members, and you see all these flags here. So 22 countries plus the European Commission. But I have to say that this year we have also, as an observer and presumably a future member, the SIDS consortium, which is the small islands developing states. and it's under the UN a group which can be so hosted as a member like the European Commission is. And why do I quote it here now? Because I think these countries are especially interested in the development and deployment of OTEC, and I'm pretty sure that in the forthcoming months or year there will be a lot of interaction with these observers and presumably new members. Then I wanted to say, just to show what kind of projects and working groups and what kind of database we develop at the OES, and highlighting everything that is, of course, related to OTEC. So we have a specific working group working on OTEC, and I will develop a little bit more on that. But it's not only this. I think that other projects, like, for instance, all the tribute which is given to the environmental effects and monitoring efforts, which is an ongoing task from the beginning of the OES, has sometimes already some recommendations for tech. So, I mean, we have to keep in mind that any anthropic action in the ocean might have an environmental impact, and therefore OTEC too, and should collaborate to this project. One of the issues, of course, is the cost of energy, and so the cost of energy assessment is something to perform for wave, for tidal, and also for OTEC, and that's a good issue. There's how do we also have a common basis for the evaluation of the technological readiness levels of the technology, and that's something we have to agree upon at an international level. This has been performed already for wave and tidal, and I think it's a task to also be performed to OTEC. Why? It's because in the near future we could say that there's a kind of international passport for technology. I mean, first steps might have been performed in one country and the next steps in another country, but all of this has to be recognized, and that's what this project is all about. Among the when you have to convince people consenting to a new kind of energy, the issue of the jobs, the number of jobs that are created by this activity is something important. In the first exercise that we've made, we have computed that for wave, tidal, and also for OTEC, but I must admit that there was a lot of uncertainties on the number of jobs, and also of the overall outreach, in fact, of capacity of reach of OTEC to perform this job very precisely. So this is something we have to work on. And the last topic is alternative markets on ocean energy, because I mean, on OTEC, and I think it will be related today too. I mean, it's not only providing electricity, but also other services and other direct benefits for the so-called blue energy that has to be taken into account, and that's why we have this project on alternative markets for ocean energy. And to come back to the task on OTEC, so just after me, I will give the floor to Anna Brito, and she will present the white book that is really something important that has been processed last year, especially with the coordination of Purnima Jailal, and a forthcoming study on the economics of OTEC, which is a little bit linked, of course, with that, or I said about the cost of energy, and the assessment of job creation, and all these things have to be clearly defined. And I think that that's among our tasks to be performed. So I won't be longer on this, and I'm very happy to participate to this workshop, to which I wish the best success. Thank you very much.
Thank you, sir. I request Dr. Anna, Member Secretary, OES, to present the activities on OTEC in member countries.
Hello. Do you see my screen?
Yes, ma'am.
Yes. Okay. So, as Secretary of the OES, I will present the OTEC activities in the OES member countries. So, under the OES, there is a task group on OTEC to promote dissemination and demonstration of OTEC. And last year, as Jan Hervé mentioned, a white paper on OTEC was published. The aim of this white paper was to serve as a guide for policymakers, and it contains a set of recommendations for the adoption of OTEC technology. What you see in this slide is the cover page of this white paper, and it's available on our website. The OES member countries with activities on OTEC are India, China, Japan, Korea, USA, Mexico, France, and the Netherlands. And I will just very briefly mention some major projects in these countries. So in Japan, we have the Okinawa OTEC demonstration facility with a capacity of 100 kilowatts. It was built in a remote island of Kumajina in 2013, developed by Saga University with industrial partners. It's a grid-connected unit, and there are previous experience with a 75 kilowatt OTEC facility at Saga University. In Hawaii, USA, we have Makai OTEC power plant. It's located in the Natural Energy Laboratory of Hawaii Authority, and NELA Laboratory. It's a capacity of 100 kilowatt, developed by Makai Ocean Engineering, and connected to the grid since August 2015. So to mention that there is much activity, track record at US on OTEC since 1974, with several activities with demonstration plans, including testing of equipments of a large-scale floating OTEC, known as the OTEC 1 project. In Korea, in response to a request from the Kiribati government, CRISU has developed a 1 megawatt scale OTEC facility to be installed in Kiribati. In 2019, alongside the International OTEC Symposium, the equipment was placed on a barge and tested in Korean waters. And it is expected that during this year, it will be transported to Kiribati, which is in the South Pacific Ocean. You can see in this map. Previous experience in Korea exists with the operation of a 20 kilowatt OTEC plant in Gongseong. In India, seawater desalination system can be derived from an open cycle OTEC system by eliminating the turbine. In this case, it's called low temperature thermal desalination. It has been very successful over several years at the Lakshadweep Islands in the Indian Ocean. It was developed by NIOT with governmental support. There are 6 desalination plants under development in the other islands, and the next effort is the OTEC plant generating power at Kavarati. CRISU undertook a survey in 2019 of worldwide operational, planned and proposed OTEC projects, and in this figure, this is summarized the results of this survey. OTEC plants range from 15 kilowatts to 20 megawatts. So we can see from this picture that there is significant worldwide interest. And I will conclude, just use my 5 minutes, just summarizing what the highlights from the white paper on OTEC prepared by OES. So there is a significant interest in OTEC and also in SWOC. In particular, it is seen as a potential solution to the energy needs of many islands and equatorial countries. For instance, small islands developing states, which is now observer to the OES, could benefit from successful OTEC developments. The technology is proven. It is a promising technology. It has been seen by OTEC plants operating in Hawaii and Japan. So there is a track record, but at a relatively small scale. Additional benefits. Although the focus for OTEC is typically the production of electricity, there are numerous co-products, and we are talking about desalination, aquaculture, hydrogen production, air conditioning. All this can improve the economic viability of OTEC. An island-based 2.5 megawatt system is achievable today, and it is an attractive market for small island developing states with governmental support, of course, for instance, feed-in tariffs. A 10 megawatt floating OTEC is technically achievable, considering the significant technical developments over the last 15 years in the gas industries. Of course, not yet commercial. And finally, OTEC relies on economies of scale, and a larger scale demonstration plant of 2.5 megawatt operating for a few years seems to be now the priority. Thank you.
Thank you, ma'am. We shall now commence the talks. The first talk is by Mr. Patrick Grandelli. Mr. Patrick Grandelli is an ocean engineer at PCCI in Alexandria, Virginia, and serves on IAC Technical Committee for Marine Renewable Energy. He has operated both open cycle and closed cycle OTEC systems. Mr. Grandelli will be speaking on 35 years, 3 OTEC plants that have used the same cold water intake pipe.
Well, good afternoon, everyone. My screen's very small. Okay. So thank you for the previous presentation. With regards to what's going on in the U.S., I didn't have too much that I was allowed to talk about. So I thought instead that I would talk about projects that have used an amazingly long-lived pipe. And I have to thank Luis Vega for many of these photos. So I'm also involved with the IEC Marine Renewable Energy Working Group, which is also the river energy, the tidal energy, and the wave energy people. And what's really interesting to watch is how much they struggle to have their systems survive for even like a 2-year test. And so there's we the OTEC people have a different story that we can tell, and that is a lot of our components can last a long time. So the what you see is the 3 OTEC plants that have used the 1 meter pipe. The 1 meter pipe in Hawaii has lasted longer than people's careers. It's lasted longer than kind of the development of computers. So let's go to the next slide. That. This is the 1 meter cold water pipe. It's the reason it has a long buoyant catenary like that is because there wasn't good survey methods back when this pipe was being planned. And so you can see the pipe emerges from a shallow trench over on the right, and then there's a seabed mounted portion that goes to about 150 meters. And then because you have good seabed bathymetry there, but not. It was kind of a lot of unknowns down deep. They didn't try to lay the pipe on the seabed. They just left at that sharp corner and took advantage of the polyethylene's natural buoyancy and then placed it down. There was some positioning problems when they placed it. I think they placed it a little too close to shore, so the pipe actually had a little bit more of a bend than was intended. But regardless, it's still there and it's still working. So at H3, you see that there was a steel clamp that held onto the pipe, and there you can kind of see two chains heading off down and to the right in the background. So in this picture, the left-hand side of that inset is the top, and the right-hand side is leading back uphill. And so what that pipe made possible was Luis Vega's open cycle OTEC plant. So here you see the water coming in. It goes to a submerged pump station, which was serviced by split submersible pumps. There was a 28-inch warm water pipe and then the 1 meter cold water pipe. And then from there, the water traveled to the open cycle OTEC plant, which is that concrete vacuum chamber that you see on the right-hand side there. And so there's a 250 kilowatt turbine generator, and then there's an extensive train of vacuum compressors to continue to remove the non-condensables from that system. And so inside the chamber, this is along the outer annulus, there you see Jim McCluskey looking at some of the evaporator spouts, and the water would come frothing like crazy out of those spouts. Later changed the spouts, so it was sort of more of a diffuser look, kind of a conical shape. And you could look in the window, you could just watch the foam as there's about 1% of the water would then flash the steam and go up into the steam attic and then enter the turbine. And there you see the turbine. That's about a 3 meter diameter at the inlet part of the turbine, and then it would enter and then turn down and head down to the center core where it was then condensed. There's the control room, and you can see that the computers were a lot older looking than they are now, and the AMX software actually was running on Microsoft DOS. Simultaneous with that, after that plant was running, then Algoods, which is a subsidiary of Alcan, the aluminum company, and a lot of other people, including GC Marconi, arranged to use that same facility with some heat exchanger tests. And so this photo is taken from standing on top of the open cycle, and there was multiple plates in this multi-stage condenser and evaporator system. And we had some problems with some material compatibilities, and thus some corrosion problems in 1996. But
Muted.
pipe lasted, and the manufacturer revised the heat exchangers, and we continued to do more testing in 1999 and 2000. And so the years passed. And so in 2006, there was an earthquake. They noticed the earthquake had occurred and that the pipe had been damaged. It was up in the shallow area because the inlet water temperature was slightly warmer and slightly less pure than it had been. It was a relatively easy thing to patch. And then Mackay then was working with NAVFAC and Lockheed and a kind of a neat group of people. And we wanted a facility that we could test heat exchangers in the vertical orientation. I think vertical orientated heat exchangers are going to be in the long run more useful. It's kind of a more convenient shape. But it's an important architecture decision when you're designing a OTEC plant. And so we have this test facility where you can put in 3 different condensers and 3 different evaporators, and there they are. And also, after a while, in 2013, we said, well, it's time to fix some of the steel in there. They've been there much longer than their 10-year design life. So they were getting kind of worn. Change some anodes, do some adjusting. And then a couple years later, we were able to get some funding, and we put a 105 kilowatt system in. And there you see it's right on the very top of that tower. And basically there's a valve, and there's a turbine, and there's a speed reduction gear and generator. The turbine spins at about 13,000 RPM, and the generator spins at 3,600. And so there's a gearbox in between. And in terms of how the technology has changed over this many years, we went from not having GPS to having the ability to film that plant with a very high quality drone. And so I commend that video to you. The resolution of that video is so good that it almost looks like it's not even real. It looks like it's a computer animation, but it is the real plant. In terms of how the years go, the boy on the left was born when we were conducting the Algoods heat exchanger tests, and so there we are in 2015. And just kind of for a comparison, you see the turbine on the right. That is about a 210 millimeter turbine for 105 kilowatt, and I put that there so you can contrast it with the open cycle turbine. So I think an important story to tell for we OTEC people is OTEC has been around long enough, and the other technologies, wave energy and so on, have been around long enough that we can make the demand that people compare the reliability of these systems. And so, Benjamin's OTEC plant in Kumijima has been there a long time. The Korea system, which I'm looking forward to them getting installed, is there. And so we can talk about other systems, and we should talk about other systems. Policymakers have to decide which projects are they going to support. And so we're at the stage where we can point to systems, and we can also point to the other competing systems and ask that policymaker to judge different things by their record. So that's kind of my main story. I mean, I know some of these pictures are old, and I'm looking at who's there, and I know many of you know of this, but maybe some of you newer folks haven't seen it all in one place. So take any questions, and then we'll go to the next presentation.
Thank you, sir. There doesn't seem to be any questions, sir. So we'll move to the next talk. Our next talk is by Mr. Berin Jan Kloot. Mr. Berin Jan is an independent expert in ocean thermal energy. In 2010, Berin Jan co-founded Blue Rise, a technology provider and project developer in the ocean thermal energy market, which was later acquired by Allseas, a renowned offshore contractor. Berin Jan is involved in various international offshore renewable energy projects in collaboration with industry and helping to accelerate the implementation of ocean thermal energy. Mr. Berin Jan will be speaking on Ocean Thermal Energy Update, the Netherlands.
Thank you for the introduction. Hope you can clearly hear me and see my slides now. Yeah, so indeed, thanks for having me first of all, and thanks. Very good to see so many familiar faces again. Yeah, so Berin Jan Kloot, I was involved in OTEC since 2010. So briefly looking back at what has been done before in the Netherlands, and I'm also looking at the current status and recent developments in the Netherlands in this presentation. So let's proceed. So first of all, we founded a company called Bluerise in 2010. Most of you know, I think, based in Delft in the Netherlands and in the Dutch Caribbean. We developed technology projects and software, and also made that available to the whole sector. And together with Delft University of Technology, we did over 100 research projects. Recently, one PhD just finalized his work on the ammonia heat exchanger, and the second PhD is currently busy with research on OTEC, focusing on the implementation in Indonesia, and also a little bit on upscaling of OTEC, and I will show some of his results in this presentation. After Bluerise, the development actually continued within Allseas, a major offshore contractor. So they basically acquired us in 2019. And within Allseas, we continued developing the 3 megawatt OTEC plant, which was planned to be built in Bonaire. And currently still the work is ongoing to make that project come alive. Allseas unfortunately stepped out of OTEC, not really because of the technology or the market. It was mainly based on the fact that they had some troubles in their balance sheets, and they wanted to focus their attention on oil and gas mainly. Some of you may know that they also have some new ambitions in deep sea mining, which was the one they were betting on, and the renewables unfortunately didn't survive the COVID period. So nothing to do with OTEC. It was mainly their vision on the future and their current financial situation. But within Allseas, we actually made quite some good advancements, both in the FEED design of the project, but also in detailed CAPEX and OPEX calculations, and in the pipeline installation methodology and plastic heat exchangers. This is an overview of the Dutch Caribbean market, where you see in the red colors that there is quite some resource available, at least in Aruba here, and in Bonaire all around, and same for Curacao. These are the 3 bigger islands, and they
Your
have
slides are not moving. Are you moving them, or they're kind of fixed? Have you been moving your slides, Berend?
Sorry?
Have you been moving your slides, because it hasn't moved at all since the first slide? Can you make it in the presentation mode?
Yeah, I just did.
It's still showing the
Okay,
view
sorry.
of the slides. So you need to make it full screen.
Once again, yeah.
We could share for you if you wish.
I think it should work now. Does this work?
Yeah, looks okay now.
Yeah, okay, so these are the 3 main islands on the top and on the left. So Aruba, Bonaire, and Curacao, which are of interest for OTEC. Bonaire has been the main focus because of their very steep seabed slope. You reach 1,000-kilometer depth within 3-kilometer distance from shore. They have pretty high electricity cost. Cost of electricity is about $0.34 per kilowatt hour, and generation cost 0.25. So that enables OTEC to almost directly, even at a small scale, relatively compete with diesel. On the other hand, Wind and solar, of course, are nowadays cheaper, but than at least the 25 cents a kilowatt hour. But if we are able to at least go through the learning curve and being helped by some government funding, yeah, definitely with OTEC we can be of help in making the energy grid more sustainable. So that's definitely still a major opportunity. So Bonaire is one of the key locations to build a 3 megawatt size plant, and there are subsidies available, and luckily also more and more from the EU, since they are now actually since recently also considering the islands outside of the EU territory, the fixed territory, so to say, also as being part of the EU subsidy framework. So luckily now also Bonaire can make use of EU subsidies, for example. Let's proceed. Bonaire has a peak load of about 20 megawatts, currently supplied with diesel mainly, about 75%, a little bit of wind and some battery storage. And they are planning to build more solar and wind in addition, increasing their peak and variable production. So this would enable also OTEC as a good solution for more baseload power in the energy mix, and their energy demand will only increase in the coming years. You'll know the variability and unpredictability of wind, at least in these regions. Even you have a capacity factor of maybe sometimes 47%, and this is a weak on the horizontal axis, but typically I think it's even lower. Sun, we all know, and OTEC as well. So OTEC can be a real good addition, not just from a baseload perspective, but also from a required area perspective. So that's good to keep in mind and to keep on stressing towards governments. This was the foreseen location on the island. It was actually foreseen to be here next to the oil terminal, with a nice, relatively easy slope, seabed slope near shore, and sort of concept design created by us. The seabed slope, I already indicated, very steep, but relatively smooth. Pipelines that we foresaw were in the order of 2-meter diameter. Intake, cold water, warm water, and 2 return pipes. We initiated contact with the local utility and local project developer, Contour Global, which were super interested to have an OTEC plant in the energy mix. So it was a matter in the end of I think a few a minor gap in funding, which was part of the reasons why it didn't continue. But it doesn't mean that it's still possible to do it in the future. This whole setup with basically the contractor, the special purpose vehicle, and the client in there. So we really saw the 3 megawatts as a way to launch and scale up OTEC towards 10 and even 30 megawatts, making use of the learning curve and lowering the kilowatt hour price step by step. Recently, actually last week, a report came out to which the industry was able to provide input about the energy solutions for Bonaire. It was performed by TNO, Dutch Research Institute, and unfortunately they mainly focused, but understandably, they mainly focused on solar and wind energy in combination with batteries. And they were asked to also research OTEC for Bonaire, and basically they did some scenario analysis of how this energy mix could look like if Bonaire would need to be climate neutral by 2030. And so they defined several scenarios, of which OTEC was slightly, very little bit part of it, which was a shame, because in the end, I think OTEC should be able to, or needs to have the chance to be able to make use of the learning curve. Otherwise, we cannot make a fair comparison between wind and solar and OTEC, because always OTEC will be more expensive than wind and solar, which already, passed the learning curve significantly. So that's basically a summary of this slide. If you would like to have access to this study, it's available only in Dutch, unfortunately, but it's available online. And it will still be discussed in the government relatively soon, I think in the upcoming weeks. This is just to quickly go through this slide. It's summarizing the whole energy mix today. So it's 29% renewable. So 11 megawatts of wind, some battery storage, and mainly diesel. They have this kilowatt hour production price, 25 cents US dollar. They proposed now to make the step towards more wind, to 24 megawatts of wind, and to increase also the solar production. With that, also they need to scale up the battery storage, and they see that as an intermediate step, and propose it as an intermediate step towards 100% neutrality, 100% renewable energy in the mix, for which they created 3 different scenarios. And here you see the challenge that OTEC sometimes faces, I think, and why we need a fair comparison between OTEC, solar, and wind, is that if you have, basically this scenario, the top scenario, you have only solar, wind, and battery storage in the mix to reach 100% sustainability. Then, of course, the production price will go up, but overall, the immense capacity that's needed in wind, solar, and battery it's pretty big. So it's huge, 10 times the peak demand. But since they didn't look, for example, in any potential limits in scaling solar and wind up, like area limits or not in my backyard limits, there was just a financial optimization that they took place, that they performed. So in the end, OTEC in the mix, the second scenario with just 10 megawatt of OTEC, didn't really came out too nice comparing it with scenario 1. It's more expensive. But one of the reasons again is that they didn't took into consideration also the learning curve of OTEC if you would scale it up a little bit more and towards 2030, etc. So there is reasons to also criticize stuff that's being produced on OTEC and be very critical as a community, because this is not the type of message that we want to give, I think, and we should at least try to make sure that people also integrate OTEC in future scenarios for the learning curve and for the benefit of having a real sustainable energy mix without too much overcapacity. So what came out of the study as suggested next steps was that they indeed also, like Anna also just mentioned, proposed to research the combination of OTEC with seawater cooling and possibilities for future cost reduction, which seems okay, especially with regards to upscaling. But it would also make sense to still have a look into, I think, more scenarios of how the future energy mix could look like. In Delft, the research on OTEC is advancing. I would skip this slide for now. Most of you are aware. We've done a lot of research. All of it is available on the repository site, which is listed here, the second link. If you go there, you find, I think, most of the documents provided or created at Delft University. So a lot of knowledge is available in the public domain. Then I would like to summarize a little bit the current PhD being performed by Jonas Langer. He's doing his research on OTEC, specifically looking into the possibilities for Indonesia, which are concentrating in the east side of Indonesia. So basically, he mapped where are the hotspots to build OTEC based on LCOE, and how OTEC would compare to wind, gas, biomass, PV, etc., geothermal. And you see here that definitely with upscaling of OTEC, there's a reason, there's possibilities to be able to compete with other renewables, like also geothermal. Yeah, and one of the conclusions, which are part of his paper, which is available also online, is that we need a certain growth rate of OTEC in order to not lose competition from wind and solar. If in the end we are too slow with integrating OTEC in the energy mix, there's no reason to add an OTEC plant anymore, and also not larger OTEC plants, for example. If we are too fast, that's also not the best way to go, because then, then we are oversaturating the energy mix with larger OTEC plants. So somewhere in the growth of OTEC, there's an optimum in the rate that we grow OTEC, in which we are able to optimize the LCOE in the energy mix. That's the outcome of his PhD, one of his outcomes, and this is to show that OTEC has a definite future in the energy mix. So please have a look into his paper. Hope I'm able to share a more positive note on OTEC for Bonaire in the near future. And thanks for having the opportunity to present to you. Thank you.
Hello, Panima. We cannot hear you at the moment.
Hello, can you hear us? This is a small issue.
Your sound has gone again, I'm afraid.
Are you able to hear me, Mr. Berend? Yeah. So there is a question from Peter. He's asking, have you considered open cycle OTEC to also take advantage of the drinking water production? And he also asked, what are the economic advantages or disadvantage of electricity plus water compared to just electricity production?
No, we didn't consider open cycle OTEC because of the less scalability opportunities. But no, so we did only consider OTEC closed cycle and focused really on OTEC. That was one of the also lessons learned a little bit from the past in Blue Rise and also in All Seas is that having seawater air conditioning is a major opportunity, but it's also quite challenging to deal with all the stakeholders and users of the cooling, of the users of the cold. You need to set up contracts with all individual parties. You need to align them and make sure that all of them are connected in one go, and also prepare all the contracts beforehand. That was to reduce the dependency on so many customers of cooling, for example. We focus mainly on OTEC.
Thank you. Thank you, sir. We'll move to our next speaker. Our next speaker is Ms. Nadia Fabina. Nadia Fabina is the founder of Lumar Energy, an Indonesian startup with a mission to build and operate ocean thermal energy conversion plants in rural Indonesia. Lumar's plant design combines zero-emission power generation with the production of fresh water and sea salt. Previously, Nadia has been with BP in the Global Projects Organization for 15 years, working on natural gas liquefaction plants and large complex FPSO vessels. Ms. Fabina will be speaking on commercializing OTEC in Indonesia.
Okay, thank you very much for the introduction. I had a difficulty to actually share my screen. I think it's something with the setting. Maybe if you could help with driving the slides.
Yes, ma'am, we'll share this slides for you.
Oh, okay. Maybe it's, wait a minute. Maybe just. Okay, let me try this one. Okay. Maybe I can do this.
We are doing it if you want.
Okay. Please do so. Thank you. Okay. Okay, good evening and good afternoon and good morning, everyone. Thank you so much for the opportunity. As introduced before, I'm Nadia Fabina. We are based in Jakarta, Indonesia. We are Lumar Energy, and we started Lumar actually quite recently, in towards end of 2019, not long before COVID. So we are focusing on commercializing OTEC in Indonesia, and we are at the moment in the early stage of our venture, let's say. So let's start could you please, next slide, please. Okay, so before we move, we talk about the commercializing OTEC in Indonesia. I'd like to give overview about what Indonesia is and the background of OTEC in Indonesia. Next, please. Okay, so Indonesia is in the equator, and you see that it's located in tropical zone around the equator, and it consists of approximately 18,000 islands, of which around 5,700 are inhabited. And most of the development in Indonesian infrastructure are in the bigger islands in the west side of Indonesia. So it's Sumatra, Java, where Jakarta is the capital, and Bali. Bali is not a big island, but its popularity makes it a populated, dense island. So, okay, next, please. And yes, next, please. So, as discussed before, the over 75% of Indonesians live in biggest islands, which is Java, Bali, and Sumatra. Next.
Nadia, we're not able to hear you. Can you hear us? You can write in the chat box otherwise. Can you hear us, Nadia? Can you type in the chat box if you're having a problem? We're not able to hear you, Nadia. I request everybody to just wait for a minute or so. If she's not able to connect, maybe there's a problem with her audio. We'll move on after waiting for another minute. Just give us some time to try to reconnect. Thank you.
Okay. Thank you, Dr. Purnima. My connection was off. I actually was down. If you could hear me now?
Yes, we are able to hear you now.
Okay. Okay. So I'm not sure where I was disconnected the last time, but okay, let me just in the slides. So over 75% of Indonesians live in its biggest islands, Java, Bali, and Sumatra. And the remainder of inhabited islands are mostly in small islands with limited infrastructure, which is in the eastern part of Indonesia. So it is very far from the where the infrastructure is. So the smaller islands currently rely on diesel fuel, which comes with financial environmental cost. And at the moment, majority of Indonesia's energy supply comes from fossil fuels, oil, coal, and gas. Next slide, please. Okay. Now, so with that background, there are opportunities for OTEC in Indonesia because of the diesel generators have been the workhorses of Indonesian small islands. But we all know that it's all diesel generators are expensive and highly polluting. And also it's expensive due to the transportation cost from the Java Islands and to the small islands. And Indonesia is also a highly populated nation. So its growing population is estimated to reach over 300 million by 2035. at the moment is about 270 approximately millions. Okay, next slide, please. Now, about 60 million people in Indonesia do not have any access to electricity. So they depend on kerosene and wood for cooking and lighting. Now, because Indonesia is an archipelago, it has huge potential for alternative energy resources from the sea surrounding its islands. And knowing that it's Indonesia also needs because of lack of electricity in that smaller islands. And OTEC is also a baseload power generation technology. So it is a good replacement for the diesel, for the conventional solution, which is the diesel generator. Next, please. Now, I'd like to talk briefly about OTEC in Indonesia. Next slide, please. So the OTEC history in Indonesia, when we started to look into OTEC, and we actually found out that there is a document from US Department of Energy dated back in May 1979. So it has been, well, I was still 2 years old by that time, so it was very much a long time ago that OTEC was actually looked at as one of the potential energy resources in Indonesia. As of date that as we speak now, there are more publications, of course, about OTEC in Indonesia, as also mentioned by Beren just before. But unfortunately, there is no yet pilot or commercial OTEC plant in Indonesia yet. Next slide, please. While OTEC potential in Indonesia is very big, I've got this a source from Marine Geological Institute of Indonesia dated in September 2017 that OTEC has the greatest potential of all ocean energy technologies. In Indonesia, tidal is 18 gigawatt, wave is 2 gigawatt, and OTEC is 41 gigawatt based on these resources. But there are more resources that actually having research on OTEC potential in Indonesia, on recent ones as well. And some of them also said that it's not for, it's actually range from 40 to 250 gigawatt. And about Indonesia itself, my view is no country in the world has more potential for OTEC than Indonesia, not only because of the physical potential, but also historically, Indonesia is is based on oil and gas, and OTEC technology is very much close to oil and gas. So we have a strong knowledge based in offshore and subsea engineering from the oil and gas industry, and it's dated back to more than 4 decades in Indonesia. It's a long history. We have had even the LNG, for example, and also the deep water offshore technologies also available here and used in Indonesia. And therefore, there is local manufacturing capability inside Indonesia. So for OTEC, this can be this is very very beneficial. And also, there is a high cost of conventional solutions, and as we discussed before, a rapidly increasing energy demand. Okay, next slide, please. So this is just illustration about the potential of OTEC in Indonesia. You can see that there's a lot of deep water, and it's pretty much approximately close to the coastline, the depth, the deep water that is needed for the OTEC. Next, please. This is just a temperature profile, so the it also has the right temperature for OTEC. Next, please. Next slide, please. Next slide.
Can you please wind up in 2 minutes?
All right. Okay. Next slide, please. Okay. Next slide, please. Next slide, please. Okay. So this is basically next slide, please. I'd like to share what we are doing in Lumare. We're trying to commercialize OTEC and how to monetize OTEC because we are private sector. So traditionally, OTEC sell the electricity generated by OTEC plant, right? So ROI can only be achieved for large scale OTEC for the economics of scale, but OTEC has not been scaled up yet. So to ask from the investors and people who giving grants people giving investments, it is that there's a little confidence in the technology because there is no something that has been ready yet. An additional complication in Indonesia. Electricity can only be sold to state-owned distribution company at a fixed low price. So it's adding an attractiveness to invest in OTEC. Okay, next please. So fortunately, OTEC has a deep sea water, is involving deep sea water, which is a commodity on itself. So what we're trying to do is we are make a small size OTEC plant and using the deep sea water to actually increase the ROI. And this has worked to increase the ROI so far. Basically using the deep sea water as an integrated business with OTEC. Next, please. Okay, so which co-products from deep sea water that we can develop first? Because in Indonesia, there's no tap water that's drinkable in Indonesia. So bottled mineral water is actually a very viable business. And the second that we think is sea salt, also a good product to develop in conjunction with bottled mineral water. And if you can see in the next, we have started our own brand in sea salt, and at the moment we are actually working with the farmers. There are in OTEC locations that we are seeing. There are some farmers, salt farmers that already starting to that have been doing that for generations. So that's also we use that to actually engage with local communities. Okay, next please. Okay, so this is my last slide. So conclusions is that we'd like to do, and this is what we are doing and we're focusing on at the moment, is that we are starting small OTEC, but profitable from the start. And we are proving OTEC through deep sea water products. And that is, and next that we can go bigger and go offshore and potentially in combination with hydrogen and ammonia. So I think my last message is that because in Indonesia, there are like other renewable energy such as biomass and biogas is very popular now to be combined with agriculture for circular economy and using that agriculture waste and then to generate electricity. But being a huge maritime country, is not the combination between ocean energy and blue economy is an area that is still underexplored. And with a large market, it is a huge opportunity. Okay, thank you. Thank you. Sorry for the technical glitches. Thank you for listening.
Thank you, ma'am. We'll move to our next speaker. Our next speaker is Dr. Satyabhama Thiruvyana. Dr. Satyabhama is currently the director of UTM Ocean Thermal Energy Center and a senior lecturer in Razak Faculty of Technology and Informatics, University Technology Malaysia, and she is registered with Board of Engineers Malaysia, IEEE IETN Energy Institute of UK and Malaysia. Currently, she is focused on ocean thermal energy conversion and its efficient technology to tackle sustainable development goals and 2050 decarbonization action plans with ONG Industries. In addition, she is the project manager for SAT REPS OTEC project. Dr. Satyabhama will be speaking on ocean thermal energy driven activities in Malaysia. Ma'am, I request you to please, can you give the presentation in about 6 minutes as we are running out of time?
Hello, everyone. Are you able to hear me?
Yes, ma'am.
Okay, and you can see my screen, eh?
Yes, ma'am.
Okay, a very good morning, good afternoon, good evening, and good night, but don't sleep to everyone. I'm Satyabhama with the team members here. Before the team members, acknowledgement to OTEC, Institute of Ocean Energy, Saga University, UTM and UTM OTEC, ocean thermal energy driven activities for Malaysia, in Malaysia for sustainability. So the common keyword that we are focusing that brings us all together, I suppose, is the sustainability that we look forward to, especially with OES here, in particular, Dr. Purima and the team. All right, so the team members are here, acknowledgement to them, and I'll proceed. Okay, you can see. So the outline, okay, quickly I'll go on. So who we are, UTM OTEC, we are a small team with some restructuring happened in University Technology Malaysia, where I come from. So we have formed this Institute of Future Energy. So as the keyword goes there, energy and future energy, sustainability and clean energy is part and parcel. And UTM OTEC is a center underneath. We also have Center of Hydrogen Energy and Center of Electrical Energy Systems. This is our upcoming conference. I would like to take this opportunity. It's going to be in July in Kuching, Sarawak. Please do check it out. And the small group that I mentioned, so this is the members here, and Nadia did mention about Indonesia, and she quickly showed the part where Malaysia is together, the map. So I would like to focus in where OTEC is potential in Malaysia. There are some islands that we've highlighted here. Of course, we can have floating on the islands, the small islands. Nevertheless, onshore is also, the onshore OTEC plant is also a good potential in Malaysia. So with the depth highlighted here in blue is the 1,000-meter depth. Water depth, having the area and the power is highlighted here. Not only in Sabah, okay, so there is another part which is closer to the Brunei called the Kuala Baram. It's somewhere here. You can see my pointer. So all these details can be checked in our the paper here. So of course, people who know OTEC, they are very well versed with all the uniqueness that is required, the temperature profile and other profiles that's which has to be profound, which is specifically near the equator, near or somewhere around the equator. So we are grateful to be in the equator. So why not maximize the potential of OTEC? And of course, energy mix is another point that we would like to highlight. But you can't really get much of a wind. So what is the use of doing wind in this part of the world? Wind is good for the temperate zones. Okay, so this OTEC, how do I close this? Oops. I'm unable to see this part here. Okay. All right, so OTEC, with an OTEC plant, not only combating the energy issues, of course, there was a question to Baron just now, why didn't you incorporate open cycle for the water accessibility. Yeah? So we can also incorporate the access to clean water, food supplies, rare earths, mining, and also another thing that the rest of the world is already doing, the SWAG, and we are also trying to propose this to the Malaysians here for data center cooling and many more to explore. So the awareness is something that we really would like to focus why we are from an academic institution. So this is the current research we've been doing, G to G with the Japanese and the Malaysian government under the project called Science and Technology Research Partnership for Sustainable Development Program, SATREPS. So there are many funders, of course, JICA, JST, Ministry of Education Malaysia, and technology providers from Japan and also Malaysia, and many universities. Then we have formed the consortium to spearhead this project. So we started in 2019, so we are already in the mid of the project. So incorporating all these 10 projects, there are some details highlighted here, which I can't really go in, but you can check the slides later. All right. So this is still a schematic diagram, as you can see, conceptual. Why? Because we yet to get the building done. So under this project, it's going to be the UPM UTM OTEC Center, as highlighted here, near the shore, on the shore and near the sea of the Telok Kemang of Port Dickson. So from the top view, you can see it's going to be here. This is the building where, and then we'll be tapping the water down because it's a little bit 12 meters height. Yeah, so down and going to the north side this way, about 100 meters. Okay, to get the surface sea waters. Then about hybrid OTEC, it's been designed, developed by the Japanese IOES. Prof. Ikigami is here, his team, and the Genesis Incorporation. So it's the hybrid OTEC system whereby the combination of the open cycle, which produces the water with the flash chamber and the evaporator and condenser, the hybrid heat exchanger there. And on the other side is the closed cycle, which produces 3 kilowatts. This is rather small R&D test rig that we call it. Of course, we don't have funds. So this is an important note to the OES here. All right. So what is the uniqueness here? Technological novelty is the highlighted, the flash chamber, incorporating that, and the hybrid heat exchanger. So which is, we anticipate, the design, we hope that it will be the most advanced OTEC system. Okay, so this is already in. So they're having the building constructed. This is the hybrid OTEC plant that's already in Japan, tested, partially tested. So designed and developed by OES, Saga University Genesis, and the test and technical evaluation will be done of this Telok Kemang in Port Dickson. Somewhere we hope that by end of this year. So somewhere in November or December this year. Now I would like to bring your attention to the Malaysian, the renewable energies in Malaysia. Malaysia Renewable Energy Roadmap that's put forward by Sustainable Energy Development Authority, SEDA, Malaysia. So this report, you can capture this from this site highlighted here. Also, this is similar to what Nadia mentioned, whereby biogas, biomass is highlighted with solar, PV and hydro. But unfortunately, OTEC is not in place. Okay, well, we don't know what's the reason behind that. However, as UTM OTEC and other institutions, we are trying to promote and bring the awareness that we are near the equator, and OTEC is the one of the potential renewable energy. So good to be placed in the energy mix. So you can check this graph that's highlighted here. By 2035, we are with the new capacity target, we hope to be having 40% of renewable energy, and with only this hydro, solar PV, biomass and biogas, kind of a doubtful. So that's why please incorporate OTEC to really achieve the 40% of the renewable energy. So this is another project by the Petronas, the oil and gas company, Petronas, with the NOS. They have signed an MOU to explore green hydrogen production. the supply chain or the model is already there. So overview of the potential collaboration is production of green, what is this, hydrogen in Malaysia, transporting it to Japan for their uses, especially to combat or to achieve the carbon net zero by 2050. I think many countries have pledged for the 2050 agenda. So in order to achieve that, this has been put place. However, the unfortunately, kind of sad though, what as a renewable energy that's put forward is wind. This part of equator, we don't really have much wind, but wind is there, and also solar PV. So we would like to propose having this on-land and offshore OTEC will be really impactful. If you really want to achieve something, which is a carbon net zero, please do consider on-land or offshore OTEC. All right. So this is something from the Lockheed Martin. I really don't want to go there because we are well versed with that. I think 10 over years, it's been visualized, put on perspective that by having OTEC plants, we can produce green and hydrogen and ammonia. So this is a proposal to the off-takers, investors. Yeah. Why? Because OES is here, Dr. Purima, and the team. So of course, we can combine the phase 1 and phase 2 just to have a a feasibility project to really and move on with a pilot plan and commercial plan for OTEC, to extend the invitation to the off-takers, to of course anchor and kickstart the commercial OTEC plant. Why? As Nadia mentioned, we still don't have a commercial OTEC plant. Okay, so the way forward, OTEC in Malaysia, this is what we've been proposing and anchoring and promoting. To have this viable business model to sustain OTEC commercial plant, which is very vital. And we come from institution, you see, academic, tertiary academic institution. So technology, education, talent development is very, very important, and not leaving behind the firm policy that Pat mentioned at the beginning of the talk. What are the policymakers thinking? We really want to know for her firm. Policy to sustain OTEC technology is vital. Why? Because OTEC, to engineer a better world. Why? Because very much focus on the carbon net zero agenda. So with that, I think I'm not behind time. Thank you very much.
Thank you, ma'am. Our final speaker is Mr. Benjamin Martin. Mr. Benjamin Martin is the Secretary General of the Ocean Thermal Energy Association, an organization of more than 400 members and observers from 47 regions and countries, which is dedicated to the realization and future growth of commercial OTEC and other ocean thermal technologies. As part of Genesis, he also serves on the Secretariat of the Global Ocean Resource and Energy Association and operates the 100 kilowatt Okinawa OTEC demonstration facility on behalf of Okinawa Prefectural Government. Mr. Benjamin Martin will be speaking on empowering islands and coastal communities towards carbon neutrality with ocean thermal energy. Sir, I request you to please complete your presentation in 5 or 6 minutes.
Okay, thank you for the introduction, and thank you for everyone joining us today. I will run through these as fast as possible then. I'll kind of skip through this. In Japan, we're focusing on deep water use because it's an established industry on the island where I live, which is Kumejima. And so it's a major industry for this island. It's one of the largest industries, and it's a major part of the local economy. And so this slide kind of wanted to introduce the resources that we have available through deep ocean water use, which there's little graphs here up on the left. You see wind and lots of nearshore energies that are very viable, but 90% of the ocean is deep sea water, and the ocean is vast. So it's a great resource that can really be used, but it's underutilized right now. So recently, through the Ocean Thermal Energy Association, we kind of looked around at where are people using deep sea water, and there's actually 38 sites with 45 pipes in the water, at least, using for various uses of deep sea water around the world right now. So it's not, a niche industry anymore. It's established, it's around the world, and it's being used, and it's growing to help people. And just last year in Tahiti, they established a new pipe for seawater air conditioning for a hospital. So it's helping people who need it the most right now. The Ocean Thermal Energy Association, as a few of our members are speaking today and have talked about, focuses on the different uses of deep ocean water and surface deep ocean water, such as CWAC, ocean thermal conversion, LTTD, and of course, deep sea water use for industries as well. But for today, I'll focus on OTEC. And we have, of course, 47 countries and regions represented with over 430 members. So it's a new but growing organization, working and volunteer organization to kind of bring all of us together and provide more information to all stakeholders. So this is where I work. I operate the 100 kilowatt OTEC demonstration facility here on Kumijima in Okinawa. It's owned by Okinawa Prefecture, and it's been established since 2013. So this facility has been in operation for more than 8 years. So we now have a track record for the entire world industry for OTEC use. For those of you who don't know, Kumijima is this little dot here. It's a small island offshore of the Okinawa mainland. So it's an islanded grid. It has its own unique culture and history. It has a small population of only about 7,000 people with an annual power generation of about 10 megawatts. So as this island is looking towards the future and looking at resources, it doesn't have a lot of tourism because there's other islands that have easier access and higher populations. There are not local resources except for the ocean. So that's why when Kumijima Town started looking at how to create energy for a clean future, in 2018, they first announced that they would work towards 100% clean energy. And then in order to put that into actual effect in 2020, they released an energy vision, which was a kind of roadmap to how they could get to 100% renewable energy based on that initial goal. And so for Kumijima, we do have some solar, no wind, unfortunately. We have typhoons, hurricanes. So in order to establish wind, we would have to overcome some technological hurdles that haven't been really adapted yet. At least not from the specification side. And then on the solar side, unfortunately, because of the island grid, in order to balance the load, the power utility is not accepting any more renewable energy without base stabilization technologies, which aren't in wide or cheap availability right now in Okinawa. So I'm going quickly, but here's generally Kumijima's current situation in terms of energy use. It's about a 10 megawatt peak, 5 megawatt average with mostly diesel, which is very expensive and even more today. So the case for OTEC is becoming more and more critical as costs go up. So how does OTEC play a part? So for Kumijima, the town energy vision foresees a 1 megawatt OTEC facility as an initial step, which would bring about 20% of the base load for the island, which is a big step. It would be a major reduction in diesel usage and also provide a base to add more solar power on top of that. So 1 megawatt is 10 times the current demonstration. So it's not a huge step. It's a one small step technologically wise, but it would require a new intake pipeline to bring that water to power the plant. As a next step towards 2035, a follow-on 5 megawatt scale OTEC facility would then allow a complete 100% clean energy for this island using both, including both transportation and full electrification of the island. With solar and some stabilization technologies such as demand response, etc. So in order to get there, Kumijima is focusing on the first step, which is a 1 megawatt onshore facility. And to use that, we would expand current industries, which are already well established, have demand for existing water and more water. And that would also allow the demonstration and development of other related technologies and a system that allows a system approach for energy, water, and food for a small area. To accomplish this, Kumijima is working towards establishing new intakes. And so new intakes are, of course, very expensive, but they provide the opportunity as a resource generator, an infrastructure that, just like water or gas, provides something that we can build from. And so for this project, Kumijima is currently in the detailed survey phase with an ongoing project this year and next year fiscal year starts in April. So from April to the second year of the project, which will have the detailed planning necessary to establish a budget and begin construction. So as a infrastructure project, the intake will operate from the income from water sales and operate the pumps and maintenance all from that internal revenue. And OTEC then would be free kind of the shackles of the intake pipeline. It would be able to produce power and sell power as on the same playing field as other renewable energies, and then be able to be cost comparative and build up to scales where offshore then could be established economically. So, for Kumejima, we have established industries that you can see here on the slide, everything from agriculture to oyster farming that are happening right now on the island. The OTEC provides resources, both not just water, but temperatures needed for these industries to thrive. And so we hope that by building up here domestically in Kumejima, we will provide opportunities for expanding these technologies around the world to islands and coastal communities that can use it. I mentioned that this has a major impact on the local economy. About $25 million a year in annual revenue comes from deep sea water industries. And actually, this is a little bit of an old figure. Most figures actually have heard that it's gone up to about $30 million a year, especially from cosmetics, which has really grown recently. Again, new industries are coming in as well. A pharmaceutical company called Lot Pharmaceutical has established a spirulina culture facility that is using spirulina to then create beer. And so they're actually covering the whole industrial development cycle from primary production all the way through service and sales and tourism through one specific product. So they're creating beer from both deep sea water and spirulina, and that creates the blue color naturally from the phytoplankton extract. So it's a very interesting kind of product using this kind of bioreactor. And so this is one initial step. And then as they grow, they can try different types of phytoplankton with, of course, the cooling from deep sea water and also the nutrients from deep sea water as well. So it's really exciting. We can also contribute to environmental protection. We have a coral nursery that uses surface seawater that's been cooled with deep sea water in heat exchangers. That also enables onshore nursery and research that can help protect the environment. So through these different industries, not just OTEC, but LTDD, seawater air conditioning, deep ocean water industries, they're all interconnected. And they can contribute to the development of both self-sufficiency and economic development, especially for islands. So for Japan, we currently have a 100 kilowatt demonstration. The next step is 1 megawatt. And then offshore would be 10 megawatts or larger as far as we see. But this parallel development onshore is really critical for these small islands are playing on global scales without the resources to kind of back them up. And that's where I think the SIDS doc comes in, where they are extremely interested in achieving their own resources, which is access to deep sea water. It's something that kind of needs to be a universal access, but it is expensive and it's hard for small communities to foot the bill for a large infrastructure project. So the benefits of OTEC and all these different industries, of course, getting more complicated creates complexities and can create more challenges as well. However, each island will have its own needs, and so adapting these different opportunities to the needs of the individual island is a critical step. But it can create an electricity security, water security, energy savings, food and economic security, and environmental security as well. It hits all the buttons, and it really is one of the major drivers that can help support the SDGs as we kind of look towards the future and see the glaciers falling off right as we speak. So I went through this really fast, and I'm sorry if I was unclear with anything. But with lack of time, I hope we've shown you a little bit of what's going on here in Kumejima with an eye towards hopefully accelerating our implementation to make it available around the world as well.
Thank you very much, Benjamin. We're really running short of time, so we'll move on to the panel discussion.
I mean, of course, we realize with online there is like many challenges, and controlling a panel discussion on online is we're trying this for the first time, so please bear with us. So what I plan to do is I'll just ask, I had in mind to ask 2 questions. Each question I would request a panelist to kind of one by one just reply to that question, so that there's no confusion with feedback and noise and things like that. Basically, we'll just straight away, we'll keep the introductions very small. We have on the panel Mr. Martin Brown from Ocean Energy Systems Limited from Scotland, Professor Ikegami, Saga University, Japan, Dr. Luis Vega, who is well known in the OTEC industry for a very long time, Dr. Vijay Kumar from the Ministry of Earth Sciences, the Government of India, Dr. James Van Zwieten, Florida University, US, and Dr. Hyunju Kim from South Korea. He is this year's OTEC award winner from the OTEA. So I'll just start with a question, and I request brief answers from everybody. So the first question I had in mind, first of all, thank you for joining this at all odd hours. The first question that I thought we should all address is, to take OTEC forward, the challenge is the techno-commercial viability. So what are your thoughts on this? And I'd request like just a minute kind of answers from each of you, so that we could also take a second question, and we'll also get a chance to hear from all of you. Martin Brown, please.
Okay, yeah, thank you, Dr. Panima. I mean, I think a key thing is that the estimated levelized cost of energy is still judged to be high. And I think a lot of that goes back to Lockheed Martin's 2010 work, which is now quite old. And I think it's vital that more recent and other estimates we've had more recently are done by smaller organizations, and that data isn't in the public domain. So I think it is very important that a respected engineering design house should develop and optimize a sort of 10 megawatt design in which they do get reliable cost data from vendors for pumps, heat exchangers, turbo expanders, so that we actually have realistic, up-to-date data for the levelized cost of energy. And that design also should take into account oil and gas experience in terms of installation of cold water pipes, floating liquefied natural gas experience with cooling, and also avoiding the deploying in the equatorial belt where there are in general no hurricanes. So I think those are key points to consider.
So Professor Ikegami, please.
Yeah, can I use share the PowerPoint?
Okay, but you just have a couple of minutes, Professor Ikegami.
Yeah, okay. So I think
You can please share the screen. You can share the screen.
Okay. So I would like to accelerate the 1 megawatt class demonstration. So then 10 megawatt. So personally, we want to organize and promoting international collaboration project 10 megawatt, but in Japan, so we have to step by step. So 1 megawatt. So now is some old OTEC project is 20 years this bottom of this barrel. So now I think this year, so OTEC enough to the high potential to commercialize, but we have to accelerate the paradigm shift to blue economy through the OTEC. So OTEC, as you know, where cost economic of the scale up. So small OTEC is not enough the economic cost. So Kumejima already realized byproduct, spin-off joint with OTEC. So until now, deep sea oil industries only use each by the usage fees pays and income. And OTEC is totally intake tube cost is very high cost, 70, 80. So we have to decrease the total cost. So we have to install the social implementation as a public infrastructure as a water supply and drainage as subways. So this sector is separate the OTEC total cost. So maintenance costs and some operation. So totally is OTEC cost is decreased dramatically. So we have to promoting the OTEC intake tubes in public infrastructures. Thank you. Okay.
Thank you, Professor Ikegami. So the next we have Dr. Vega. Thank you so much for staying up, and I can see you're just all set to sleep. But thank you so much for joining, and we request a few words from you.
Yes, aloha. As you know, it's 2 o'clock almost in the morning for me. I did send some answer to your questions, and maybe you can share later on. And also, I would like to beg our friends from Indonesia, Malaysia, and even India. I wrote a report for the Asian Development Bank in 2014, and really still pretty up to date. And I beg for you to get a copy of that and glance at it and read it, because some of the things that you're talking about have been discussed before, and I think are well documented. And that report doesn't only just address my work here in Hawaii, but of course different people, but also work done by others. I was just a good reporter finding information from my friends, especially my friends in Japan, my friends in South Korea, that have done such magnificent work. And I also was really benefited from information that I acquired about the offshore industry thanks to Martin Brown. He really was helpful by making those connections with me, so that I feel really confident in saying that there are no technical challenges left. The challenge is economic and environmental impact challenge that we have to address. But we know that we can produce electricity 24/7, the same with desalinated water generation with no CO2 emissions. And also, I was one of the first people to put together in a document in the 1990s, actually, the idea that proved that there's a real market economy of scale for OTEC, such that for you to be competitive, you have to get to 50, 100 megawatt plants, with the exception of some small line of development states, like in the case of our friend Ben Martin in Okinawa. But it's a small situation, really. But what we did also here in Hawaii with Dr. News was he implemented a computer model that includes thermohaline circulation, air-sea interactions. And he took the whole of OTEC region and put a 100 megawatt plant in each 25 or 25 kilometers square, and just at once turn them all on to see what will happen to the environment. And we concluded what he did conclude, and working earlier with myself, that we could perhaps achieve half of the electricity produced required on planet Earth could be generated using OTEC. But that is a theoretical model, and we also have developed a protocol to assess the environmental impact. So once you begin to deploy real plans, you can assess the environmental impact and then decide whether or not to continue. So the information is available. And one thing I would like to say in closing my 2 minutes as fast as I can is that, please, I beg you, OTEC produces electricity and desalinated water. If you cannot use the electricity directly, then you might consider producing ammonia or hydrogen. Please remember that you need 4 units of electricity to go through the process of generating hydrogen that would allow you to produce 1 unit of electricity. You go 4 to 1 to be able to do that. So don't just make hydrogen for the sake of making electricity unless you need it to be taken far away, like in the middle of the ocean, to support some kind of offshore situation. So just please keep that in mind, and don't just throw hydrogen there as a saving situation. Hydrogen is a really specific niche market. OTEC produces electricity that you should use directly as much as you can. Thank you.
Thank you, Dr. Vega. Dr. Vijay Kumar, please.
Yeah, good afternoon, good morning to everybody, and thanks to Dr. Purnima for giving this opportunity to be a panelist on this thing. Being, you can say, I'm a non-technical person related to the OTEC technology. So my comments is related to the technical commercial viability. Is that yes, there are challenges related to technology and commercial, but I think technology wise now we have done some work. I think all the countries including USA, Japan, Indonesia, Malaysia, Netherlands, and many other countries have some experience on the technology for OTEC. So we have reached at a stage where we can say that just technologically this is feasible, but just commercial viability we have to look, because we have not reached up to the stage where we can have a full-fledged with the high capacity OTEC plant. So that thing is still going on, but I think in the future when all the governments, all the countries are going for a non-fossil fuel or energy, I think the commercial viability will be available. As such, the high cost can be used when we don't have other options. So I think in the future this commercial viability will also be there. So thank you.
Thank you, Dr. Vijay Kumar. Dr. James.
Thank you very much. I'd like to echo what others have said, that that most, if not all, of the technical challenges appear to have been resolved by either oil and gas or the OTEC community itself. The one remaining challenge seems like it could be the cold water pipeline for the really large plants, the 50 or 100 megawatt plants. However, some of the technology, such as those developed by Lockheed Martin or oil industry, may be suitable for these applications. But obviously, these haven't yet been demonstrated on such a massive scale, or the 50 to 100 megawatt plant. Also, the potential environmental impacts are not fully understood. The numerical modeling has suggested that, has been powerful in suggesting that these impacts could be mitigated by releasing the water below the photic layer. But monitoring mid-size 5 or 10 megawatt plants has been suggested could go a long way to answering these questions by actually making the observations. And for example, kind of a local solution would be if I'm South Florida, which is and the water that goes between South Florida and Cuba has a pretty good OTEC resource down here. And so if we use about 0.01% of the cold water that goes through the Florida Straits, we could support a 100 megawatt plant, or 2% of this cold water could provide the electricity necessary to support the entire state of Florida. However, the environmental impacts of either of these scenarios hasn't really been, I don't think, fully understood until we get a 5 megawatt. And as these plants grow, we can monitor and, get a better understanding of that. But I think, it'd be really nice to, as government or as we get support and these larger plants get into water, I think a lot of these questions will be answered. Thank you.
Thank you. And Dr. Kim, please.
Thank you, Dr. Zalia. Good morning. I'm so happy to see Dr. Luis Vega, live resident of OTEC, and other worldwide OTEC friends. In my answer to first question is to develop economical OTEC technology is to be the key challenge at present and the future as well. in a target area, more economical technologies have to be applied than fossil fuel energy and other renewable energies, considering environmental compensation and energy storage costs. To develop the economical technology, at first we have to find a way to lower the capital cost for the entire system and key components through material and structure improvements. And second, it is necessary to reduce operational costs related with maintenance and repair costs for rotating machinery and seaward contact surfaces by the enhancement of bearings and surface modification. Finally, for mass production and installation, digital twins will also be a useful technology to reduce operation and maintenance costs. As you know, the LCOE of photovoltaic and offshore wind power is declining to 3 to 8 cents per kilowatt hour, right? OTEC must also be demonstrated at acceptable LCOE through mass production and application to niche market. In the off-grid or microgrid unit for small island countries in equatorial belt, OTEC will be competitive compared to solar and wind power generation systems, which require 5 to 6 times the installation capacity and 4 to 5 times the energy storage systems. Of course, it would be better if the maximization of benefits such as district cooling, desalination, and so on by use of discharged cold deep sea water from OTEC plant in the viewpoint of cost sharing. I would like to emphasize again this economical OTEC technology. And second answer about the second topic, I think that first penguin is absolutely required at this moment. The government is recommended to make proactive investments to stimulate OTEC developers to dive into cold sea for economical technology development. As an example, public investments by advanced countries can be provided through bilateral or multilateral ODA projects, extend official development aids to help underdeveloped countries for achievement of SDGs based on OTEC plants and downstream utilization. For that, policymakers can contribute to make best practice for OTEC realization, as well as for extension of ODA projects. Through the process, I think that track record will be accumulated and economical technology can be advanced well, as much as we expected. After the government or public sector reaches OTEC demonstration to a certain stage or level, competitive companies can be participated and they will spread OTEC plants for commercialization in my viewpoint. Let me finish my discussion. Thank you.
Thank you very much, Dr. Kim, and you also answered the second question. I know we have just now crossed the time, but what I request is, the second question I had wanted to ask you was, what in your opinion should the governments and policymakers do to take OTEC forward? If any of you would like to take a minute and answer this, we can just extend for just 5 or 6 more minutes.
Actually, I have explained the my opinion about the second question about what my opinion should governments and policymakers do. I have already explained.
Maybe just come in there. I mean, one thing I think that would be very good, particularly in the present environment, is if a ring fence tax was introduced on oil and gas companies, which must be spent on renewables. There is such a thing already in Brazil. And you know, because the oil and gas makes a lot of money, that investment can build up, you know, the pool can build up quickly, and therefore there's a lot to be available to spend. And another important thing, I think, is to support research into the possible carbon dioxide reduction potential from if you discharge your nutrient-rich deep water above the photic zone to boost marine life. So if you're doing that deliberately and you're doing it in the deep ocean, not close to land, then there is, I think, some potential there. And also for, you know, the European Union and the US to introduce feed-in tariffs that are dedicated to OTEC produced power. Final thing just to say, educating young people on OTEC, the likes of Dan Gresh with Global OTEC and his TikTok videos is fantastic. You know, it's this publicity which we really need, because, you know, it is a select audience at the moment. More people need to understand the full range of benefits. Thanks very much.
Dr. Vijay, you're from the government. Would you like to say something?
Yeah, thank you, Dr. Purnima. So I think regarding what action government and policy makers can take to take forward the OTEC, I think from government side, as we have seen, not many private companies are involved now in OTEC because we have discussed this techno commercial viability. We are not sure about that thing, and the private companies don't want to put the money to have more research on this thing. So I think from government side, I think the government should provide funds to the institutes, to the research institutes and the universities to carry out research in the field of OTEC field. And initial cost towards the setting up of some demonstration plants can be given by the government. So I will take the example from India. India is now focusing more on the ocean energy, and all the funds are being given by government of India to different institutes for this thing. And my ministry is also supporting OTEC under the recently approved or launched Deep Ocean Mission. So one of the vertical under that Deep Ocean Mission is related to the OTEC studies. So this type of impetus by the government given to the different institutes and universities, I think will be very useful and will be very helpful to take the OTEC technology forward. And as said by my other panelists, I think to encourage the startups and to the young scientists to involve them in this type of research, I think will be very useful. Thank you, Dr. Purnima.
Thank you, Dr. Vijay. Dr. Vega?
Yes, can you hear me?
Yes.
Oh, great. No, I really believe, like I concluded a long time ago, thanks to our friends in South Korea, Japan, and Guru Martin Brown, we need to build something in the order of 5 megawatt plant ship. But I don't think that you can expect private industry to do that. You need to do it through the government funding. But we're talking about $300 million to $500 million, depending on how much you want to include. And that, you know, of course, we need funding also to keep training our students and doing basic research. But OTEC is not going to move forward unless we spend that kind of money. And perhaps we should learn from what happened in Germany and in Denmark to develop wind energy. It was developed with funding from the German and the Danish governments, and now it's completely commercial. And of course, most turbines now come from China, but it was developed in Germany and Denmark. And likewise with photovoltaics, well, thanks really to the space program in the US that we have photovoltaics now. I have it in my house, for example. I'm completely independent from the power company because of that. But we have to spend the real money. That is in the order of $300 to $500 million to implement a floating plant. It would take 5 years from the time you get the contract to be able to buy the components, install them, and operate the plant before you can expect industry to take over and then use that information to then build up 50 to 100 megawatt plants throughout the OTEC region. But if we don't move to something like a 5 megawatt plant, we are going to continue doing small plants like we've done before. And I have nothing against a 1 megawatt plant for a small island. I'm all for it. But that's not just what's going to make OTEC happen worldwide. Thank you.
And two more gentlemen, Dr. James, quickly.
Okay, thank you. I just one quick note is that it's clearly seen the presentation on OTEC from in Okinawa, the ability to provide baseload renewable energy generation will enable countries, especially those without traditional hydropower, to transition away from fossil fuels. While the government investments in wind generators and PV systems have been critical for helping start this transition away from fossil fuels, baseload power such as that what can be created from OTEC will be critical to maintaining grid stability as the percentage of renewable energy generation increases. So, I mean, that while that transition was started with PV and wind, something like OTEC is going to be critical for moving to higher percentages of renewable energy in a lot of these countries. And, you know, definitely something to actually get that moving, such as a 5 megawatt plant, would be very, very beneficial. So thank you.
And last but not the least, Professor Ikegami. You're muted. Professor, you're muted.
Sorry. Thank you for Dr. Prima. So, as I proposed, we have to promoting, accelerate the understanding. Intake tube is public facilities. User have to pay, so we can operation with including OTEC. So 1 megawatt, 5 megawatt. So accelerating the commercialize. Now in Japan is already planning the within 5 years. So 1 megawatt OTEC plant is commercialized using separate the intake tube and the power plant. So we have to promoting understandings by government. Thank you.
Very much. We have come to the end of this webinar today. First of all, I'd like to thank OES for their willingness to sponsor it. Thank you all for your willingness at various odd times, your willingness to participate. We have a YouTube link where some people have participated and there are some questions. What we'll do is we have put a note there, a message there that if they want to ask the question, we can send it to the required person and they can respond on email because the time is short. You can take a screenshot also. Take a screenshot. Yeah, and we have recorded this session. So in case anybody would like to, have it, please let us know. We'll organize that for you. Once again, thank you all very much. And I think personally, it was a really interesting 2 hours. We don't know how the time just flew by. Lot of interesting inputs and new data that we could, get from the various countries. I wish this could have been physical. There would have been much more interaction and it would have been much more easy. I'm sorry for any technical glitches that might have occurred. This is a first time experiment with combining talks and panel discussion as well. So I thank OES chair and member secretary and vice chair also was there for quite a bit of time, Matthias. So I thank all of you and all the panelists Thank you once again, and let us keep the momentum up, and we can probably have more webinars of this and like this in the future. Thank you all very much. Anna, we can conclude. You would like to say anything in the end?
It was really informative, this webinar. Very interesting information shared by all. That's all I think we can conclude, unless the chairman wants to give the final words.
Well, thank you, Anne. I was also very, very happy and very interested by all the talks that and all the information shared. And I think there's indeed a bright future for OTEC, which so far didn't have such a big part in the OES. It has a part, but not as much as it deserves. And I'm really convinced that there will be more done together as a collaborative work on OTEC. Thank you again for all.
Thank you very much. So we'll sign off now. Thank you all once again.
Thank you.
Thank you.
Thank you, Prima.
Thank you.
Dr. Prima.
Bye-bye. Thank you.
Thank you,
Bye-bye.
Prima.
Thank you for arrangement.